The last time this volcano erupted was about 500 years ago, but recently, small tremors have grown really frequent, to such an extent that scientists have been recording more than 1,000 a month. I'm talking about the Campi Flegrei supervolcano in Italy. At one point, just a few weeks ago, the area was rattled by a 4.4 magnitude earthquake with 150 tremors in just one night. It was the strongest earthquake in over 40 years. A lot of locals spent the night in their cars, but in the morning, the shakes were followed by another earthquake, a bit weaker with a magnitude of 3.6. So, is Italy in danger? Well, the quake itself wasn't big enough to cause serious damage, but it evoked a lot of panic. At the moment, local authorities are working on grandiose emergency plans. If worse comes to worse, they'll have to evacuate hundreds of thousands of people. One of the reasons is the proximity of this area to Naples with more than 3 million inhabitants. At the moment, they're even considering an option of paying people to leave their homes. Right now, schools remain closed in the Campi Flegrei area. The authorities are allocating more than 500 million euros to ensure the safety of buildings and constructions in the area. A yellow alert is still in place in the region where 80,000 people live. There's the so-called red zone, which is the most dangerous area. There are 1,250 houses in this red zone, and all of them will be at high seismic risk if an eruption begins. Plus, more than twice as many will be at medium risk. Italy is a country prone to seismic activity, and Pozzuoli is a densely populated area that is located on one of the most dangerous supervolcanoes in Europe. Campi Flegrei has 24 hidden underground craters and dwarfs the better-known Vesuvius. Yes, the very volcano that wiped the ancient Roman city of Pompeii off the face of the earth in 79 CE. This city thrived near the base of Mount Vesuvius at the Bay of Naples. In the time of the early Roman Empire, 20,000 people lived in Pompeii. They were merchants, manufacturers, farmers, and others. The soil in the region was rich and fertile, so there were lots of orchards and vineyards. Strangely, no one knew that this black earth was the legacy of an earlier eruption of Mount Vesuvius. The area was a favorite summer destination for rich Romans. Sadly, at noon on August 24, 79 CE, all this prosperity came to an end. The peak of Mount Vesuvius exploded, sending a 10-mile-high mushroom cloud of ash and pumice into the stratosphere. For the next 12 hours, the eruption was wreaking havoc on the city. Volcanic ash and a hail of pumice stones, some of which were 3 inches in diameter, showered Pompeii. It forced the city's occupants to flee in terror. Around 2,000 people holed up in stone structures and cellars, paralyzed by fear. They hoped to wait out the eruption. Who knows? Maybe if they had decided to leave the city immediately after the beginning of the eruption, they would have had some chances to survive. A westerly wind protected the city from the first stages of the eruption. But soon, a giant cloud of hot ash and gas rushed down the western slope of Vesuvius. It engulfed the city, burning everything in its way. This disastrous cloud was followed by a flood of volcanic mud and rock, which completely buried the city. As if the volcano was making sure no one would survive, a cloud of toxic gas poured onto the city, finishing the lives of a few survivors on August 25th. A flow of rock and ash followed. It collapsed roofs and walls and turned the city into a giant cemetery. When a supervolcano erupts, the consequences are usually catastrophic. Supervolcanoes have at least once had an eruption with a volcanic explosivity index of 8, which is the largest recorded number on the index. Supervolcanoes are often extremely large, with no cone at all. That's because they're typically the remains of gigantic magma chambers that once flared up, leaving behind a caldera. They're usually located over hotspots and appear when huge volumes of magma are trying to escape from deep underground. Eventually, they burst through Earth's surface. Sometimes, all this magma gets stuck, unable to break through the planet's crust. And then, massive pools of pressurized magma gather at a depth of several miles. The pressure keeps growing because more and more magma is trying to get to the surface. At one point, a super eruption goes off. The most recent super eruption happened in New Zealand. Well, when I say recent, I meant around 26,500 years ago. That's when a supervolcano beneath the surface of Lake Taupo spewed into the air more than 300 cubic miles of ash and pumice. Imagine 500,000 Great Pyramids of Giza flying up into the air at the same time. That's how incredibly powerful that eruption was. But the most exciting and confusing thing about the eruption was that the Taupo volcano didn't simply go off like many others. At first, everything was going as usual. Tons and tons of pressurized magma had built up under the surface, and the pressure was getting higher and higher. But after the rock cracked and the first portion of lava rushed out of the crater, something went wrong, and the supervolcano took a break. Only several months later, the disastrous eruption shook the ground. Thousands of tons of lava, rocks, and ash flew high into the atmosphere. The unusual pattern of Taupo still confuses scientists. The Indonesian eruption at Toba caldera 75,000 years ago was the largest eruption in the last 2 million years. Experts estimate that the eruption could have released hundreds of thousands of tons of sulfuric acid, which might have even caused a several-degree cooling of the planet's surface. But nowadays, the impact is hard to detect because of glaciers that covered the ground afterward. There are also several so-called supervolcanoes that haven't lived up to this name yet because they've never produced any super eruptions. For example, in 1883, Indonesian volcano Krakatoa went off. The power of the eruption tore the volcano's walls open, and cold seawater rushed into its molten insides. The difference in temperatures made the volcano blow up with a deafening boom. It was clearly heard 3,000 miles away in Australia. It earned the blast the title of the loudest sound in history. But even though the consequences of this event were truly catastrophic, it still turned out not powerful enough to be called a super eruption. It only had a volcanic explosivity index of 6. Then, there's also Mauna Loa. It's a shield volcano, which means it won't produce explosive eruptions, but its sheer size makes this monster of a volcano extremely dangerous. At the moment, the volcano seems to be at peace with its surroundings. Research equipment doesn't show any signs of activity on Mauna Loa, but if Mauna Loa did suddenly erupt, lava flows could reach the ocean and the most populated and touristy places like Captain Cook very fast, in a matter of hours. The last time the volcano erupted, lava got as far as the outskirts of Hilo on the other side of the island. That's where the University of Hawaii is located. Luckily, people had a few weeks' warning to get ready for the disaster. Over its recorded history, Mauna Loa has been erupting pretty regularly, almost every 6 years. On the bright side, big island volcanoes including Mauna Loa aren't really very volatile. That's because they're shield volcanoes. These volcanoes got such a name because they aren't really very high and resemble a warrior's shield placed flat on the ground. Shield volcanoes are formed by very fluid lava. It travels way farther and forms much thinner flows than the lava erupted from a stratovolcano, which is conically shaped and tall, like the infamous Krakatoa in Indonesia. So, if Mauna Loa erupts, there probably won't be ash clouds or tons of debris. The most dangerous thing will be lava. Since Mauna Loa is a shield volcano, its lava is extremely fluid and voluminous, which allows it to flow far and fast. For 70,000 years, Taftton volcanoes successfully convinced everyone it was extinct, but new satellite images show that its summit is rising, like something inside is stretching it, rolling it over, and cracking its neck after the world's longest nap. Scientists aren't too happy about it, so let's see if you have a reason to be worried too. Volcanoes can wake up when earthquakes shake them awake or storms mess with underground water. But scientists checked. There weren't any big earthquakes or heavy rains in southeastern Iran, where it sits. So it must be gas or magma pressure that's moving Taftton. It's like a sealed soda can heating up from the inside. Before you even hear a hiss, the pressure is building silently, waiting for a weakness. That's why Taftton's movement is such a big red flag. Pressure changes mean new internal activity. Plus, the source of pressure below its surface is at just around 1,600 to 2,070 feet deep. And that's not a lot for a volcano. When the source of pressure sits that close to daylight, it can set off small explosions from steam or gas, even if no lava ever touches the surface. This type of explosion, called phreatic, happens when water underground gets so hot so fast that it blows up like a giant pressure cooker. In Hollywood movies, volcanic eruptions always look like rivers of lava chasing people down the street. But steam-driven explosions are different, sneaky, and unpredictable. One minute everything looks calm, and the next minute rocks and superheated steam blast into the air like Earth sneezed with the power of a jet engine. For Taftton, this is exactly the scenario scientists are afraid of. You don't need flowing lava to cause destruction. A steam-driven explosion can launch boulders the size of cars and shoot ash clouds thousands of feet up. Even if you don't live anywhere near Iran, Taftton isn't just a local issue. Volcanoes breathe out gases that travel with the wind, and Taftton produces sulfur-heavy emissions when it's active. Sulfur dioxide doesn't just smell bad, but messes with air quality, irritates lungs, and reacts in the atmosphere to form particles that can dim sunlight and cool temperatures. That means neighboring countries might feel the effects even if they never see the volcano. And if a phreatic explosion blasts ash high enough, it could drift into international flight paths like volcanic confetti nobody asked for. Even smaller eruptions can have ripple effects. Remember that time a volcano in Iceland with a name I won't ever pronounce correctly blew up in 2010? It disrupted all the air travel across the Atlantic, and in our case, a modest ash plume drifting into major air corridors could ground flights across the Middle East, South Asia, and beyond. You know, gas emissions don't respect borders. They drift, mix, and settle wherever the wind decides to drop them. Alright, all this sounds pretty creepy, but with all the modern sensors, scientists should find out about an eruption in advance, right? Not really. As Taftton sits in a really remote region, setting up monitoring stations there is tricky, expensive, and frankly, was never a priority because everyone assumed the volcano was done for. So right now, satellites, not ground instruments, are doing most of the work. Satellites see the big picture, but instruments on the mountain add detail. And that's why it was so important for Taftton to be reclassified from extinct to dormant. Because dormant volcanoes need eyes on them 24/7. When a volcano is labeled extinct, countries don't invest in evacuation plans, hazard maps, or monitoring equipment. Changing Taftton's status forced everyone, from local officials to global scientists, to admit it can cause trouble. And that means preparing for ashfall, gas emissions, sudden eruptions, and the long-term questions. Questions like, what if this awakening isn't temporary? What if this is the beginning of a whole new activity cycle? Long-term, Taftton might settle down again, or it might be entering a period of renewed activity. Volcanoes don't run on human timelines. A short-term phase for a volcano could be days or years, and the uplifting summit might mean there's deeper magma movement, not just a surface burp. It has gone up by about 3.5 inches over 10 months between July 2023 and May 2024. And a mountain rising is like Earth inhaling. And if Earth inhales too deeply, it eventually exhales. And in volcanic terms, that exhale is nothing good. Right now, Taftton is breathing in, and nobody knows when it plans to breathe out. This already sounds like too much drama, but there's more where it came from. some of the biggest, angriest supervolcanoes on Earth are starting to wake up. When one of these monsters erupts, the whole planet feels it, even people living thousands of miles away. Scientists worry because a super eruption could move faster than our ability to prepare food, evacuate cities, or deal with the chaos afterward. That's what makes supervolcanoes so scary. Not just the explosion, but how little time we might have to react. If you live near Naples, you already know at least one supervolcano and how it acts. Streets crack, steam leaks from the earth, the harbor fills with sediment, and swarms of small earthquakes rattle windows like underground thunder. All of that comes from Campi Flegrei, a massive supervolcano caldera that last erupted in 1538. For years, scientists read these signals as classic warnings of magma rising. But two recent studies, one in 2023 and another in 2025, completely changed how we understand what's really going on. And surprisingly, they brought a bit of hope with the danger. In 2023, studies zoomed in on carbon dioxide, a gas volcanoes pump out when magma starts acting up. At Campi Flegrei, CO2 levels jumped after 2005 to about 4,000 to 5,000 tons a day, which sounds like magma rising fast. But when scientists checked other gases like nitrogen and helium, the chemistry didn't fit that idea at all. It turned out that the extra CO2 came not from rising magma, but from super hot fluids underground, cooking the surrounding rocks and releasing gas on their own. In the 2025 study, lab experiments showed that the shaking comes mainly from a sealed underground water and steam reservoir. When that natural lid traps pressure, it eventually cracks and releases steam and sets off sudden quakes that people feel at the surface. That idea also explains something that always confused scientists. The earthquakes usually start close to the surface and then move deeper, which is the opposite of what rising magma would do. After the strongest shaking, the ground often sinks a little, like a balloon slowly deflating after you let some air out. None of this means Campi Flegrei is suddenly safe though. Magma still sits deep underground and steam-driven explosions can still blast out rocks, ash, and scorching gas without any lava warning you first. What's really changed is how scientists think about the danger. Just watching and waiting isn't enough anymore. If humanity only had 12 months of warning before a supervolcano eruption, we'd struggle badly. Stockpiling food, relocating people, keeping supply chains alive. It would all feel almost impossible. But don't freak out yet, because supervolcano eruptions are extremely rare. The last one happened about 26,500 years ago in New Zealand. On average, scientists think a super eruption happens roughly once every 100,000 years, but Earth doesn't follow neat schedules like a calendar. Sometimes these eruptions cluster closer together, and then the planet stays quiet for a long time. Two massive super eruptions shook the planet within the last 100,000 years. About 74,000 years ago, Indonesia's Toba volcano blew up with such force that it blasted ash across Asia, lowered the temperatures around the world, and may have pushed early humans to the brink of extinction. Then, around 26,500 years ago, New Zealand's Taupo volcano unleashed an eruption, covering huge areas in ash and reshaping the landscape we see today. There's always a chance another super eruption could arrive earlier than we expect. That uncertainty is what keeps scientists awake at night. At first, researchers thought their cameras were glitching. It was the only possible thing that could explain the weird view in front of them. Scalding water was blasting upward while cool methane was fizzing out right beside it. Such a combo wasn't supposed to even exist, but it did. Scientists were exploring the ocean floor near Papua New Guinea when they stumbled across a weird deep-sea hotspot. It wasn't like any other hotspot. There, super hot and cool methane-packed gas were bubbling out almost side by side. This almost never happens in nature, so the researchers were pretty shocked. They were cruising around with a deep-diving robot, the Rove Keel 6000, poking around underwater volcanoes in a remote island chain. These volcanoes hide all sorts of strange features, but nobody expected to find a full-on hydrothermal vent just tucked down there. Plus, other research trips had passed through the area before and missed it completely. This time, the robot's cameras lit up the seafloor and revealed a bizarre view: boiling vents and cold gas seeping out of the seabed. They were practically touching each other. As you understand, normally these two things show up in totally different places. Hot hydrothermal vents form when underground water gets cooked by magma and shoots upward, carrying minerals with it. Methane seeps, on the other hand, come from cold, mushy layers of sediment packed with old organic matter. This stuff slowly breaks down and leaks out as gas. But at this spot, the geology created a perfect mashup. Under the volcano sits a thick layer of organic-rich sediment. Magma creeping up from below heats these sediments, but at the same time, it also heats mineral-rich water deeper down. So you get two very different fluids, blazing hot vent water and cooler methane gas. Still, both are traveling upward through the same cracks in the seafloor. When they reach the surface, they escape just inches apart. So you end up with this bizarre little neighborhood where boiling mineral water and chilly methane bubbles are hanging out like best buddies. To ocean scientists, this is like discovering a unicorn that can also fly. It's weird, rare, and super exciting. An even more exciting thing is that right next to those weird hot and cold vents, an entire mini world of creatures has taken over the rocks. The place is packed with huge clusters of deep-sea mussels, long tube worms, little shrimp, and amphipods crawling everywhere, and even bright purple sea cucumbers sitting out in the open. The animals are so crowded together that it's hard to even see the rock underneath. Scientists are pretty sure some of these creatures are totally new to science, but they'd need a special trip just to identify everything living there. The strange mix of hot fluids and methane-heavy gas also changes the rocks themselves. The methane down there is super concentrated, while hot water coming from deeper inside the volcano brings chemicals with it. Together, they create unusual reactions underground. Because of this, metals like gold and silver have built up in the rocks, along with elements like arsenic, antimony, and mercury. It's like a chemical time capsule. The rocks show signs of an older, super hot phase when precious metals were forming. Today, the vents are cooler, but still active. Now, even though this deep sea area is rare and full of life, it isn't safe. Mining already happens nearby, and waste from the huge gold mine on Lihir gets dumped into the ocean. On top of that, companies have licenses to explore the seafloor for minerals and gas. All of this puts the fragile vent community in danger because many of the animals here can only survive in these exact conditions. So scientists are urging for more research and strong protection plans before this one-of-a-kind ecosystem is damaged beyond repair. This underwater treasure needs to be saved before industry wipes it out. This discovery, though, isn't the only unique ecosystem we've ever found. In January 2025, a gigantic iceberg named A84, roughly the size of Chicago, cracked off Antarctica's George VI ice shelf. This ice shelf is enormous on its own, stretching about 280 miles from end to end and about 820 feet thick. During the Antarctic summer, which is November through late February, the top of the ice shelf melts and forms long, skinny pools called ribbon lakes. They got that name because they really do look like giant icy ribbons stretched across the surface. Once A84 broke free and drifted off, it exposed part of the seafloor that had been sealed away under the ice for who knows how long. It was a place absolutely nobody had seen before. A research team aboard the ship Falkor 2 happened to be in the Bellingshausen Sea at the time. As soon as they got word about the iceberg breaking loose, they ditched their original plan.
This was basically the deep-sea version of flipping over a huge rock in the woods just to see what's living underneath it. For 8 days, the scientists sent down their underwater robot, Sebastian, and explored depths of more than 4,200 feet. Down in that freezing darkness, they discovered a hidden ecosystem packed with life. Huge corals and sponges formed underwater neighborhoods that were absolutely crawling with creatures. They were not just barely alive, they were thriving. So yeah, the scientists expected to find something down there, but they definitely didn't hope to spot a full-on underwater city of ancient life. There were sea anemones that looked like tiny fluffy trees, sea spiders marching around like creatures from other planets, ice fish, octopuses, and a whole mix of other animals. The entire expedition was live-streamed to researchers around the world. By the way, the recordings are still publicly available if you're interested. Even cooler, the researchers think some of the creatures they saw might actually be brand new species. That's right, genuinely new species in Antarctica in 2025. A few might live only in this one area, and that makes sense because Antarctica is basically its own isolated planet. It's surrounded by the Antarctic circumpolar current, which acts like a giant watery moat that has kept the continent cut off from the rest of the world for millions of years. But even if the new species ended up being known ones, the scientists still found some extremely rare animals, like tiny snails, bristly worms, aka polychaetes, little crustaceans, and even the mysterious phantom jellyfish, which already looks like something from outer space. The scientific name for the phantom jelly is Stygiomedusa gigantea, but no one really needs that mouthful, so giant phantom jelly is fine. This thing is massive. Its bell, the umbrella-shaped top, can be more than 3 feet wide. It also has 4 long ribbon-like arms that can stretch up to 33 feet. That's the length of a school bus. Actually, the first one was collected in 1899, but scientists didn't even realize it was a completely new kind of jellyfish until 60 years later. Its body is mostly see-through with a ghostly purple tint, and instead of normal tentacles, it uses those big flowing arms to grab prey and feed itself. Even though jellyfish don't have brains, the way this giant phantom jelly moved caught scientists off guard. It seemed to steer its long arms with surprising control, especially when it drifted through tight spaces near the seafloor. It looked cautious and almost intentional, which is kinda unsettling. Another maybe kinda sorta smart creature lurking in the dark ocean? Great. The researchers also found bristleworms. Officially, they're called polychaetes, but bristleworms sounds way more fun. These worms are common in cold, deep oceans and come in tons of shapes and sizes. Their bodies are made of segments lined with tiny bristles that help them crawl, sense the environment, and defend themselves. One standout is the Antarctic scale worm, which has shiny golden bristles that make it look surprisingly fancy for a creature living in freezing darkness. So, as you see, there are still tons of places and things on Earth that don't seem real or aren't even supposed to exist. And even with our level of technology, we're unlikely to figure out all the wonders the world has to offer in the near future.
Get ready, because one of the Pacific Ocean's most active volcanoes might blow any minute now. Scientists monitoring Axial Seamount, a gigantic underwater lava factory just off the coast of Oregon, say it could erupt literally any time between today and early 2026 at the latest. Yes, it's underwater, but don't get tricked by the ocean's cover. This beast is almost 3 times taller than the Empire State Building. This volcano is inflating like a souffle at a Michelin-starred restaurant, and scientists are so excited they will live stream it. Seriously! So here's the thing. This volcano will explode at any moment now because, well, it's inflating fast. Over the past few months, researchers have noticed that the seafloor is literally rising. It's like Axial is doing its best impression of a waterbed filled with molten rock. Scientists call this inflation, which sounds like something you'd complain about after Thanksgiving dinner. But in volcano terms, it means magma is piling up underground, causing the seafloor to bulge like a souffle that's this close to collapsing. Now, an underwater volcanic eruption might not sound so exotic. After all, most volcanic activity on Earth happens under the sea. Believe it or not, there are more than 1 million submarine volcanoes quietly churning lava beneath the waves as you watch this. The ocean floor is Earth's biggest volcanic hotspot. What makes Axial Seamount so thrilling is that it's under intense scientific surveillance, unlike any other underwater volcano. It's like the star player in a volcanic reality show, with a network of ocean-bottom instruments giving researchers real-time updates on magma movements, seismic tremors, and crust deformation. In fact, Axial Seamount hosts the world's first-ever underwater volcanic laboratory. Scientists have been keeping a constant eye on it since the 1990s, when they installed sensors that now relay live data straight from the seafloor. This kind of monitoring is unheard of elsewhere and has turned Axial into a geological celebrity, one whose behavior we can track with remarkable precision. Besides, Axial is hilariously predictable. It erupts roughly every decade, and right on cue, it's gearing up for another performance. By mid-2024, it had inflated to nearly the same level as before its last eruption, which means the countdown is on. Scientists are so confident in its schedule that they've set up a volcanic advent calendar, waiting for the day when Axial decides to pop. But hold on, Axial Seamount isn't just your average underwater volcano. It's got style, personality, and a geological identity of its own. Now, most underwater volcanoes, called seamounts, tend to look like cones or flattened domes. Axial laughs in the face of tradition with its unfashionably rectangular caldera, a 2-by-5-mile crater that looks like it was designed by a geologist with a ruler and a grudge against curves. Most volcanoes opt for the classic circular look, but Axial, it went full avant-garde. This caldera is punctuated by fissures, vents, lava channels, and mysterious dome-like structures that rise hundreds of feet high. It's like the volcano's wearing a funky geometrical crown instead of the usual rounded hat. What's more, Axial's location is like prime real estate for geological fireworks. It sits right where two major forces collide, literally. First, it's on the Juan de Fuca Ridge, an underwater mountain range formed where two tectonic plates are slowly pulling apart, like a zipper being undone. Second, it's perched atop the Cobb Hotspot, a deep mantle plume that acts like Earth's sneaky magma espresso machine, pumping molten rock from deep inside the planet and fueling a whole chain of seamounts. To put it plainly, it's like the tectonic plates are reluctant dance partners, sliding away from each other, while the Cobb Hotspot acts as the DJ, turning up the heat and keeping the magma party going. This dual influence creates a complex plumbing system inside the volcano, with magma chambers filling, draining, and shifting in ways scientists are still trying to decode. The competition between the spreading plates and upwelling magma is what gives Axial its unique geological fingerprint, and it's also why this volcano keeps surprising us. Now, we said that Axial Summit isn't just a crater. The truth is that inside, the action gets even weirder and cooler, well, hotter, but you get it. Axial hosts black smoker hydrothermal vents, which blast superheated water at temperatures exceeding 700 degrees Fahrenheit. This is no ordinary underwater hot tub. These vents create one of Earth's most extreme environments, where bizarre creatures thrive in total darkness and scalding heat. Giant tube worms, crabs, colonies of bacteria, and even octopuses live off the mineral-rich plumes that gush from these vents, forming ecosystems completely independent from sunlight and photosynthesis. It's like an alien world beneath the waves, thriving off the volcano's fiery breath. These vent communities are crucial to science, not just because they're strange, but because they may resemble the earliest ecosystems on Earth. Some researchers believe life on our planet may have originated in similar deep-sea hydrothermal environments billions of years ago. Studying them could also help us search for life on icy moons, like Europa and Enceladus, where similar vents might exist beneath their frozen surfaces. When Axial erupts, It's like a natural reset button for these communities. The lava wipes everything out, but within months, life comes roaring back. Proof that even in the most hostile environments, real estate is always in demand. For those worrying about tsunamis or coastal disasters, relax. Axial eruptions are the underwater equivalent of a slow cooker. The immense water pressure keeps things chill, well, scalding, but not explosive. So the worst thing that happens is some lava decorates the seafloor, and a few crabs have to find new vents to squat in. This means no massive ash clouds or explosive blasts that could reach the surface. Instead, lava oozes out and spreads across the seafloor, sometimes traveling for miles. But for scientists, this eruption is the golden ticket. Understanding axial patterns could help predict eruptions elsewhere, even on land. Plus, its bizarre ecosystems offer clues about how life might survive on other planets. Not bad for a volcano that mostly just sits around looking rectangular. Still, the volcano's activity can be heard in the form of thousands of small earthquakes every day. Thousands! As if the volcano itself was groaning and creaking, preparing to burst open. Again, we won't feel a thing, but at least they'll help scientists track the magma's movements and the volcano's eruptive cycle. Now, one of the coolest parts of this story is that scientists are preparing to live-stream Axial's next eruption for the first time ever. Imagine watching an undersea volcano in action, live, as it's painting the ocean floor with fresh lava. It's like a front-row seat to a natural fireworks display, thousands of feet beneath the waves. The livestream will come courtesy of the Ocean Observatory's initiative, which maintains a series of fiber optic cables linking Axial's instruments directly to shore. It's the Wi-Fi of the deep sea, and it's about to broadcast molten rock in HD. And there's another twist. Scientists have noticed a curious pattern in Axial's eruptions. All three of its most recent eruptions, in 1998, 2011, and 2015, happened between January and April, the months when Earth starts moving away from the Sun. So why? Well, it might have something to do with the Moon's gravitational pull. The Moon's orbit causes ocean tides to rise and fall, which changes the pressure on the seafloor and could help nudge the magma chamber to its breaking point. I guess the Moon isn't just a romantic light in the night sky. It might be the ultimate volcanic whisperer. So, one thing's for sure, when Axial goes, it'll be the best documented underwater eruption in history. So, keep your eyes peeled. This is one natural spectacle you won't want to miss. And who knows, if we're lucky, we might even get deep-sea eruption ASMR out of the deal. Now, if you'll excuse me, I'll be refreshing the live feed like it's a Taylor Swift ticket sale.
There's an old volcano in Bolivia called Uturuncu. It hasn't erupted in about 250,000 years, so you may think that's the end of its story. But recently, it has started to act a little strangely. At the moment, it resembles a zombie that's waking up from a long nap. Uh-oh, is that kind of apocalypse nearing? Uturuncu is a huge mountain in the Andes that's almost 20,000 feet tall. It's called a stratovolcano, which means it's big, steep, and cone-shaped. These kinds of volcanoes are made from layers of lava, ash, and rocks. They can have terrifying, powerful, explosive eruptions because their lava is thick and traps gas inside. Think of it like a shaken-up soda that's ready to burst. Famous ones like Mount Vesuvius are just like Uturuncu. And do you remember about the tragic fate of Pompeii, completely destroyed during the eruption of Mount Vesuvius? Does something similar await Bolivia? Even though Uturuncu has been quiet for a long time, scientists have noticed that it's been letting out gas, rumbling with small earthquakes, and even making the ground around it bulge, kind of like it's stretching. So, people started wondering if it was getting ready to erupt again. Scientists decided to take a closer look at this situation and found out that liquid and gas moving around under the volcano is causing all this activity. It doesn't mean the volcano is definitely going to erupt, but it helps explain why it still seems alive. let's dive into details. Since the 1990s, scientists have been using satellites and GPS to keep an eye on the ground around the Uturuncu volcano. At one point, they noticed something weird. The ground was rising in the middle and sinking around the edges, kind of like a sombrero hat. The middle part has been slowly going up for at least 50 years by about 0.4 inches a year. It doesn't sound like a lot, but hold on. This strange shape, along with lots of tiny earthquakes and gas like carbon dioxide coming out of the volcano, made scientists think that there might be a giant blob of magma growing under the mountain. If that were true, it could mean only one scary thing. The volcano could be getting ready to erupt. Uturuncu sits on top of a huge underground pool of magma called the Altiplano Puna magma body. This pool is really big and really deep, stretching under parts of Bolivia, Chile, and Argentina. Scientists thought that magma from the APMB might be rising and collecting near the surface, which could lead to an eruption. But now, after studying more than 1,700 earthquakes and checking the rocks around the volcano, scientists have a new idea. Apparently, it's not magma rising up. Instead, hot fluids and gases are traveling up from the APMB through a narrow path shaped like a chimney. These gases, like steam and CO2, can get trapped under the top of the volcano, while salty water, brine, spreads out sideways into tiny cracks in the rocks. This moving gas and water can make the ground rise and fall and cause small quakes, without any magma getting close to the surface. So the good news is, Uturuncu probably isn't about to erupt. If it did happen, it would cause serious damage to nearby communities and even pose a threat to human lives. Lava flows could reach towns tens of miles away from the volcano, and volcanic ash could even spread across Bolivia, Argentina, and Chile. Luckily, even though the volcano is still alive and rumbling, it's not as dangerous as scientists once thought. This discovery might help scientists figure out if other volcanoes around the world are getting ready to erupt. Now, let's visit Alaska, where according to researchers, Mount Spur might erupt soon. It's letting out strange amounts of volcanic gases from the top and side vent, the very vent that last erupted in 1992. If it erupts again, it could cause problems for airplanes flying nearby and might send ash falling from the sky. The good news is that nobody lives close to it, so people are safe for now. But even though Mount Spur isn't super dangerous, there are other volcanoes around the world that could be really destructive. One of those is Campi Flegrei, a giant volcano system near the city of Naples. Instead of one big mountain, it has 24 craters spread across the area. It last erupted in 1538, but its biggest eruption happened about 40,000 years ago. That explosion covered the whole Mediterranean region in ash and made temperatures drop by up to 16.2 degrees Fahrenheit in Eastern Europe, which led to a very cold volcanic winter. If Campi Flegrei erupted again today, it could be very dangerous. It might cover Naples and nearby places in ash, causing earthquakes and landslides, and create air pollution and acid rain. Scientists are keeping an eye on it, especially after a 4.4 magnitude earthquake shook the area in March 2025. But the good news is, there's no sign that magma is rising to the surface right now, which means an eruption isn't expected soon. Still, since Italy has a lot of volcanic activity, experts continue to watch it carefully. Mount Vesuvius is also in Italy and is one of the most famous volcanoes in the world. It's known for its huge eruption in 79 CE that buried the Roman cities of Pompeii and Herculaneum. The last time the volcano erupted was in 1944. Today, Vesuvius is even more dangerous because over 3 million people live near it. around 700,000 people are living illegally right on its slopes, which puts them even more at risk. If the volcano erupts again, it could send rocks and ash flying through the air at nearly 100 miles per hour and cause major destruction, possibly even wiping out Naples. And still, scientists believe a big eruption from Vesuvius probably won't happen for a few hundred more years. But since it's still an active volcano, researchers continue to monitor it. Cumbre Vieja is a volcano on the island of La Palma, which is part of the Canary Islands. It last erupted in 2021. During that eruption, lava poured out of the volcano and flowed all the way to the sea. It destroyed over 3,000 homes, but luckily, thousands of people were safely evacuated, so it wasn't as bad as it could have been. In the past, scientists were worried that a huge eruption could cause the entire western side of the volcano to break off and crash into the ocean. This could create a mega tsunami, sending massive waves hundreds of feet high across the Atlantic Ocean. But more recent studies have shown that this is very unlikely to happen. Mount St. Helens is a volcano in Washington State in the United States. It had a massive eruption in May 1980 that ended the lives of 57 people. That eruption also caused the biggest landslide ever recorded. Hot, pressurized magma exploded from the volcano, shooting ash 15 miles into the sky. Ash covered a huge area, and around 230 square miles of land was destroyed. Mount St. Helens is still active and is expected to erupt again someday, possibly even in our lifetimes. But experts say it's not likely to have another huge sideways blast like the one in 1980, thanks to a deep crater that is now formed at the top. It will change the way the volcano might erupt. Popocatépetl is a big, active volcano in Mexico. It's been slowly erupting on and off since the early 2000s. It's really close to a lot of people, just 40 miles from the Mexico City metropolitan area, which has about 22 million people, and 30 miles from Puebla, which is home to about 6 million inhabitants. If Popocatépetl had a huge eruption, it could cover Mexico City in thick ash as much as 8 inches deep. That ash could block drains, mess up the water, and even stop the electricity from working. Even worse, fast-moving lava and super hot flows, called pyroclastic flows, could rush down the mountain and destroy towns nearby. The volcano was quiet for 50 years, but now it rumbles and shakes pretty often. There have been over a dozen small eruptions, including some as recent as February 2024. Some nearby places got covered in ash, but scientists say this isn't too surprising, and they're keeping a close eye on it. The floor is lava! Haha, just kidding. But honestly, it's kind of falling apart. You might not feel it yet, but a huge part of North America has already lost 37 miles worth of rock from its foundation. And no, this isn't about earthquakes or giant sinkholes. It's about the continent losing pieces of the very thing that keeps the ground from wobbling around like a bad carnival ride. A team of researchers has just dropped a geological bombshell. Part of North America's ground is thinning out like a very sad, very slow ice cream drip. How do they know? They basically gave Earth a high-tech full-body MRI and created 3D maps showing how rocks once considered indestructible are now melting away into the planet's guts, like an upside-down cheese pizza inside an oven. But to really understand this mess, you first have to meet my old friends, cratons. Cratons are like the roots of the continents. They're thick, tough, and ancient. We're talking billions of years old. These bad boys survived meteor impacts, supervolcanoes, and even the tectonic movement of plates. If the plates got into fistfights, for example, you can bet we would see mountain ranges being born. If they got a divorce, drifting apart from each other, then a whole new ocean would be born. All of these things leave scars on the surface of Earth. but the cratons seem to always remain unfazed, like the cockroaches of geology. And since a craton can basically get punched in the face and feel nothing, scientists always assumed these things were nearly indestructible. But then, a group of researchers took their fancy machines to the test and realized that, wait, the cratons are falling apart? How? Enter the Farallon Plate, a really ancient tectonic plate that started to slide under North America's major plate over 100 million years ago. This is a pretty normal process, actually. It's called subduction, and it's how Earth recycles rocks and keeps itself from overheating. This subduction thing has been happening for so long that, by now, the Farallon is almost 400 miles away from the craton, sitting pretty chill at the lower mantle, weirdly close to the outer core of our planet. But the Farallon has been causing trouble, like that one roommate who moved out but keeps leaving weird stuff in the fridge. You see, as it sinks, it tugs on the bottom of North America's foundation, stretching it out and causing pieces to fall off into the deep mantle. And if that wasn't enough drama, the sinking Farallon has also leaked water and carbon dioxide into the surrounding rocks, making the craton even softer and easier to shred apart. Thanks, Farallon. Very cool of you. By studying hundreds of earthquakes across thousands of monitoring stations, scientists have confirmed the story. Big chunks of continental material are dripping downward, thinning the craton by as much as 37 miles. That's more missing rocks than can fit into a milk carton. Sounds dramatic, right? But don't worry. This is happening at a snail's pace. It'll take millions of years for anything noticeable to happen. Your great-great-great-great few grandkids from the distant future might still be standing on solid ground. But don't get too comfy. This thing may not be an urgent problem, but there's another type of sinking that's happening faster than you can say, "Help." Here's the thing. By 2050, at least 32 major cities in the US, including New York, Baltimore, and Charleston, could be partially underwater. And guess what? This one is mostly our fault. Scientists noticed that since 2007, some cities have been sinking into the ground between 0.04 and 0.08 inches every year. Charleston, in South Carolina, is pulling ahead in the worst way possible, sinking 0.15 inches annually. Sure, these numbers sound tiny and a bit ridiculous, but Charleston is barely 9 feet above sea level, and a little sinking goes a long way when the ocean is breathing down your neck. On really bad flood days, people there have to abandon their cars and basically swim home. This whole phenomenon is called land subsidence, and when you mix sinking land with rising sea levels, you get a disaster cocktail of flooded streets, salty farmland, ghost forests, and a lot of very cranky homeowners. And it doesn't stop with just homes. Infrastructure like bridges, roads, airports, and power plants, all things we rely on daily, are also at risk of serious damage. Flooded electrical grids and sunken highways could cause billions more in economic losses and create major safety hazards for communities. Now, let's be fair. Not everything is humanity's fault. Some of this trouble dates all the way back to the Ice Age. About 12,000 years ago, massive ice sheets covered the northern US. They were heavy, like seriously heavy. The weight pushed the land down, and when the ice melted, the ground didn't just pop back up like a trampoline. Instead, it started playing a weird game of geological seesaw. The places that were squished started rising, and the places that weren't got pulled down. This whole process, called glacial isostatic adjustment, try to say that 3 times fast. But of course, humans found a way to make it worse. Groundwater extraction is a major culprit. Think of it like pulling the stuff out of the mattress. After a while, the whole thing just sags. In places like California's Central Valley, the land is dropping by up to 8 inches a year because we keep pumping out water during droughts. In cities like New York, the problem isn't just water. Skyscrapers themselves are making it worse. Yep, turns out if you stack millions of tons of concrete and steel onto soft ground, it tends to flatten. And in case you're wondering, the total mass of New York City's buildings is around 1.68 trillion pounds. That's about the same as 3.5 million statues of Liberty piled up. With so much weight concentrated over a relatively small area, the underlying soils have no choice but to compress over time. And if you thought it couldn't get messier, think again. We've been building dams, which stop rivers from delivering fresh sediment to coastal areas. That sediment is kind of like Mother Nature's way of fluffing the ground back up. Without it, coastal lands are compacting like an old sponge. Plus, when wetlands are drained for agriculture or construction, the peaty soil dries out and collapses. Honestly, it's like the ground just can't catch a break. Scientists also noticed that the areas that used to be lush wetlands are now among the fastest sinking spots in the country, especially along the Gulf Coast. Louisiana, for example, is losing about a football field of land because of this mix of subsidence and rising seas. So what's the end game here for us regular people who just want to live above sea level? Well, it's not looking great. Ghost forests, which are basically drowned woodlands, are popping up. Farmland is turning salty and unusable. And even sunny day flooding, where streets flood without any rain, is becoming a thing. Yikes! Meanwhile, over on the West Coast, California is not exactly winning either. San Francisco and Los Angeles are both sinking, which means that rising sea levels could hit them twice as hard and twice as fast. In some places, like the Palos Verdes Peninsula, the ground has been sinking so fast, people over there might as well live like moles. So, is America turning into the next Atlantis? Probably not next week, but without serious action, like cutting back on groundwater pumping and planning smarter cities, at least 500,000 people are in serious danger. And the housing damage could easily rack up a jaw-dropping $109 billion by 2050. In the end, while North America isn't about to sink like a poorly made souffle, it's definitely showing some cracks in the crust. So maybe let's ease up on groundwater pumping, rethink how and where we build, and invest a little more in keeping our feet dry. After all, if the floor really does become lava someday, we're gonna wish we had at least fixed the leaks first. While you're watching this video, pieces of continents are slowly breaking off from below and are pulled down into the oceanic mantle, a hot, mostly solid layer that moves slowly under the seafloor. As soon as these fragments reach the mantle, they can trigger volcanic eruptions in parts of the ocean where there are no volcanoes. Plus, when continents break apart, it happens not only at the surface, but also deep down. But more on that later. This process can continue for tens of millions of years. The new study shows that Earth's insides are even more dynamic than we thought. It also explains why many volcanic islands, including Christmas Island in the Northeast Indian Ocean, contain unusually high levels of certain chemical elements. The thing is, these elements are normally only found in continental crust. Well, scientists did suspect that these elements showed up because some powerful forces deep inside the Earth took old, recycled pieces of rock and mixed them into the mantle. This process works a bit like when you mix together ingredients for cake batter. But before, researchers believed those elements came from two main sources: sediment that sank into the mantle as oceanic plates got pushed down, or from mantle plumes. Those are columns of hot rock rising up from deep inside Earth. However, these explanations don't fit all observations. In some volcanic areas, there's almost no sign that the crust has been recycled. In other places, the mantle seems to cool and too close to the surface to be affected by the rising hot rock. Scientists used to wonder how this could happen. Now we know that some of the material in those regions comes from pieces of continents that sink deep into the mantle, and these pieces affect the volcanoes that form above. The new study also suggests a curious idea. Continents don't just break apart at the surface, they peel away from below too. And this can happen over much greater distances than scientists thought before. Researchers used simulations to figure out how continents and the mantle behaved when stretched by tectonic forces. Their work is built on earlier research showing that when continents split, deep, powerful forces inside our planet create a mantle wave. This wave moves along the base of the continent at depths of about 90 to 125 miles. The wave moves extremely slowly, about a millionth of the speed of a snail, and gradually strips material from the roots of the continents. These peeled-off fragments are then carried sideways, sometimes more than 620 miles, into the oceanic mantle. Once there, they can trigger volcanic eruptions in the ocean for tens of millions of years. The research also shows that the mantle continues to feel effects of continental breakup long after the continents themselves have separated. Even after a new ocean basin forms, the mantle keeps moving, reorganizing and transporting enriched material far from where it originally came. To make this conclusion, researchers studied geochemical data from different parts of the Earth, including the Indian Ocean Seamount province. That's a chain of volcanic formations that appeared after the supercontinent Gondwana had broken apart over 100 million years ago. Their computer models and chemical tests showed that right after the supercontinent Gondwana broke apart, a lot of magma with unusual chemicals pushed up to the surface. Over millions of years, this chemical signature slowly faded as less material came up from under the continent. The most unexpected discovery is that this happened without any help from those deep, hot columns of rock scientists used to think were needed. Now, to get an even clearer picture, let's sneak a peek into our planet's insides. Earth is about 4.6 billion years old. It was born from a huge cloud of dust and gas that slowly cooled, shrank, and hardened into the planet we know today. As it cooled, heavy metals like iron and nickel sank to the center, and lighter, rocky materials floated upward. This created the Earth's layered structure, with each layer having its own unique properties. The crust is like Earth's skin. It's our planet's outermost layer, made of solid rock. It's broken into huge pieces called tectonic plates that slowly drift over time. There are two kinds of crust: oceanic crust and continental crust. The oceanic crust is about 4 to 6 miles thick. It's covered with a thin layer of sediments like sand, clay, and shells. Below that are dense rocks like basalt, rich in magnesium. As for the continental crust, it's thicker than oceanic crust and is located under continents. It's made of lighter rocks than oceanic crust. Beneath the crust is the mantle. It makes up more than 75% of Earth's volume. The top of the mantle is pretty rigid, but deeper down it becomes soft and partially molten, which allows it to flow slowly. This flow is what moves the tectonic plates. At the center of the Earth lies the core. It's made mostly of iron and nickel and has two distinct layers, the outer core and the inner core. The outer core is a liquid layer of iron and nickel. It's insanely hot, up to 10,800 degrees Fahrenheit, as hot as the surface of the sun. The outer core also generates Earth's magnetic field, which protects us from harmful solar radiation. The inner core is solid because of the crushing pressure inside the planet. It's also made of iron and nickel. Now, the Earth's outer shell, called the lithosphere, is made up of the crust and the uppermost part of the mantle. It's broken into large pieces, called tectonic plates. There are a few super large plates and many smaller ones. 6 of the major plates are named after the continents they carry, like the North American, African, and Antarctic plates. But even those smaller plates play an important role. For example, the tiny Juan de Fuca plate is responsible for many of the volcanoes in the Pacific Northwest of the United States. The plates are moving like a jumble of old conveyor belts. They move very slowly, about 1 to 2 inches per year. But over millions of years, this movement shapes the face of our planet. Most earthquakes, volcanoes, and mountain building happen where plates meet, pull apart, or slide past each other. There are three main types of plate boundaries: convergent, when plates move toward each other; divergent, when plates move apart; and transform. That's when plates slide sideways past each other. When tectonic plates collide, the crust crumples and buckles, forming mountain ranges. About 55 million years ago, India crashed into Asia, slowly creating the Himalayas, the tallest mountains on Earth. The collision continues today, so the mountains are still rising. Mount Everest, the highest point on Earth, may even grow a tiny bit taller over time. At some convergent boundaries, an oceanic plate dives under a land plate in a process called subduction. The land above lifts up, forming mountains, and the sinking plate melts and triggers volcanic eruptions. This is how some mountains in the Andes of South America were formed. When two oceanic plates collide, one usually slides beneath the other, creating deep ocean trenches, like the Mariana Trench in the North Pacific, the deepest point on Earth. These collisions can also form underwater volcanoes that eventually rise above the ocean and turn into island chains, such as Japan. At divergent boundaries, tectonic plates move away from each other. In the oceans, magma from deep in the mantle rises to fill the gap. This creates underwater mountains and volcanoes along the seam. This process renews the ocean floor and slowly widens the ocean basins. By the way, a single mid-ocean ridge system connects all the world's oceans, making it the longest mountain range on Earth. On land, when plates pull apart, they form giant valleys, such as the Great Rift Valley in Africa. If this stretching continues over millions of years, East Africa could split off to become a new landmass. One famous example of transform boundaries is the San Andreas Fault in California. Unlike convergent or divergent boundaries, transform boundaries usually don't create mountains or oceans, but the grinding motion can cause powerful earthquakes, such as the 1906 earthquake that destroyed much of San Francisco.
It was April 2025 when geologists went back to Yellowstone's Norris Geyser Basin for the first time this year. And while doing their usual check, they realized that something was different this time. Where there used to be just a boring patch of ground, now there was a giant hole, about 13 feet wide, filled with weird, milky, light blue water. Everyone was terrified. Was it the sign that the Yellowstone supervolcano was ready to erupt? If so, it would be a worldwide disaster, the kind that destroys cities. According to the U.S. Geological Survey, if such an eruption occurred, the after effects would be felt all over the world. To start, the areas immediately surrounding Yellowstone would experience pyroclastic flows. That's the lava that erupts out of a volcano, including a high-density mix of volcanic gas, ash, pumice, and hot lava blocks. Those flows would destroy everything they touch, and an eruption of Yellowstone would send them into Wyoming, Idaho, and Montana. Areas further away from Yellowstone would escape the flows, but they would experience falling ash. It would come down heavily in the states closest to the epicenter. The ash would be especially dangerous for anyone breathing it in. The weight of the ash would also pose a serious threat. It would smother crops and collapse buildings as it piles up. Tragic consequences would be countless, but we'll talk about them later, because soon after the discovery, the weird pit surprised even experts. Geologists found rocks scattered everywhere. Some were about a foot across, and all of them were dusted with gray mud. This mud matched the walls of the new spring. It was like the place had simply exploded, but nobody had actually seen it happen. The team checked old satellite images to figure out when it appeared. In December 2024, the ground was totally normal. By January 6, 2025, a little dip had formed. And by February 13th, that water-filled hole was finally there. But the weird thing was that the sensors that usually pick up major hydrothermal explosions didn't detect anything. There was no giant blast or warning signs. Later, it turned out that this puzzling opening in the ground hadn't just popped up in one huge explosion. Instead, it formed from a bunch of smaller bursts over time. Little explosions first threw out rocks, then mud, and eventually created the pit. With time, it filled with silica-rich water. That was a huge relief for everyone. Yellowstone sits on a supervolcano, and its big explosions are a nightmare scenario. Luckily, this time, it was just a slow-building, small-scale explosion. It was dramatic, sure, but totally manageable. You see, Yellowstone National Park is full of geysers, hot springs, and all kinds of natural landscapes. But under the surface, things get incredibly intense, all because of the supervolcano. Now, supervolcanoes are often extremely large. They often have no cone at all, since they're typically the remains of gigantic magma chambers. Once, those chambers flared up, leaving behind a caldera. They're usually located over hot spots. It's no surprise that supervolcanoes can produce super eruptions, and when they do it, they blow more than 240 cubic miles of ash, molten rock, and hot gases up into the air. In other words, 4 super eruptions could fill the Grand Canyon to the brim. Supervolcanoes form when huge volumes of scorching hot magma escape from deep underground. This magma rises close to the surface but can't break through Earth's crust. So, a pressurized pool of bubbling magma gathers at a depth of only several miles. The pressure keeps growing because more and more magma is trying to get to the surface. And then, bang, a super eruption occurs. Now, back in 2015, researchers at the University of Utah mapped out the main magma chamber of the Yellowstone supervolcano and were shocked by its size. And then, they found another one below it. Together, these underground magma pools could hold enough molten rock to fill the Grand Canyon 11 times. All that magma pushes up on the ground above, which is why Yellowstone rises about an inch or two every year. That slow lift might not sound like much, but combine it with the fact that Yellowstone is still an active volcano and has a volcanic explosivity index of 8, and it's enough to make you wonder what could happen if things went south. And yes, Yellowstone has indeed been a bit jumpy in recent years. In March 2023, there were 354 earthquakes in the area. Most were tiny, but the biggest hit a magnitude 3.7, part of a swarm of 106 quakes. Now, before you freak out, experts from the Yellowstone Volcano Observatory say there's no need to panic. No eruption is coming anytime soon. Volcanoes don't stick to a schedule. Just because Yellowstone hasn't erupted in a long time doesn't mean it's about to blow. The park is stable for now, but scientists are keeping a close eye on everything underground, the quakes, the rising ground, and even temperature changes, just to be safe. The superhot plume of magma, a hotspot under Yellowstone, has been churning for 17 million years. The Earth's crust slowly moved over it, making the hotspot leave a trail of volcanoes stretching more than 450 miles along the Snake River Plain. Most of those ancient ones are now buried under layers of lava and sediment. In just the past 2.1 million years, Yellowstone has unleashed 3 cataclysmic eruptions, so massive they managed to reshape the land. Each explosion sent pyroclastic flows, rivers of searing hot rock, ash, and pumice racing outward for miles. The debris piled up in layers hundreds of feet thick, some forming solid lava-like rock. When those eruptions emptied the underground magma chambers, the roof collapsed, forming the massive calderas we see today. Even after those mega eruptions, Yellowstone didn't stop. Between 180,000 and 70,000 years ago, enormous rhyolite lava flows, sometimes over 144 cubic miles, poured out. Some flows followed north-south vent lines. The West Yellowstone flow erupted around 110,000 years ago. The Nez Perez Creek flow followed 160,000 years ago. If you stand at Madison Junction on the caldera's northwest rim, you can see it, a cliff that formed when the Lava Creek Tuff eruption collapsed the land 640,000 years ago. And inside the caldera, you'll see the hardened lava flows snaking across the floor. Figuring out when a supervolcano might blow is like being able to read nature's warning signals. Thousands of years before a massive eruption, the heat underground starts building, and the magma chambers become like ticking pressure cookers. Little signs start showing up. Gas bubbles escape as the pressure shifts, and earthquakes shake the ground. The land above slowly rises. Cracks appear. Hot springs and geysers start acting up, heating even more than usual. Now, what would happen if Yellowstone erupted? Remember those pyroclastic flows we talked about before? They can contain two parts: the lower flow of the hot lava that moves at ground level, and a cloud of ash that follows above the lava level. So the two of them would devastate huge areas. The ash would even reach Europe within 3 to 4 days of the eruption, but it wouldn't be so bad there. After that, it would only take around 2 to 3 weeks before cooler temperatures set in around the globe, all thanks to the sulfur gas that would get to the upper atmosphere after the eruption. Scientists predict that global temperatures would drop by up to 10 to 12 degrees. These consequences could last for 6 to 10 years, putting an end to monsoons, which could cause widespread famine in Asia. Scared? Well, don't be. The good news is that scientists don't believe that the sleeping giant under Yellowstone National Park will wake up in our lifetime. Experts say the next Yellowstone eruption won't likely happen for hundreds of thousands of years. And even then, it may not be that bad, because scientists have discovered that the magma lurking within Yellowstone is actually split up amongst 4 different chambers. Not only that, but some of the reservoirs of magma are likely to cool down and solidify, lessening the chances of an eruption. So, while an eruption does sound like it would change the landscape of the world, it's very unlikely to happen anytime soon. If all the volcanoes on Earth suddenly erupted together, it'd be loud. We'd also have around 1,500 of these formations bursting at once. Now, normally it's just 10 to 20 volcanoes that are active each day. But what would the world look like if they all blew their tops simultaneously? Geologists think it wouldn't be pretty. Even if only the land volcanoes erupted together, it would set off a chain reaction way worse than anything we've ever seen before. The two big problems would be ash and volcanic gases. While the explosions in lava would be damaging for people nearby, the real danger lies in what happens next. A thick layer of ash would cover the planet, blocking out sunlight completely. No sunlight means no photosynthesis, which means crops would fade away and temperatures would drop considerably. And all this ash cloud could remain in our atmosphere for up to 10 years. Now, ash aside, there's also acid rain to worry about. Volcanic gases like hydrochloric acid and sulfur dioxide would mix with the atmosphere and fall back down as acid rain. This type of weather would harm the groundwater and ocean surfaces. Even if humans would find a way to survive up to this point, we'd have no corals and no other sea creatures around. Scientists have seen similar events in Earth's history at a smaller scale. Big volcanic eruptions have been linked to mass extinctions. When Mount Pinatubo erupted in 1991, it cooled parts of the world for 2 years. But the extra carbon dioxide from these eruptions could also heat the planet, the same way we turn our stoves to broil for that extra crispy layer on our casserole. Geologists also mentioned that there's evidence in our atmosphere that stuff like this may have happened in the distant past. During the Cretaceous period, carbon dioxide levels were way higher than today, which made it difficult for marine life to thrive. Who would survive all this? Probably just some extremophiles, these organisms that survive in harsh conditions like hot springs or deep undersea vents. As for humans, we could all lay low in underground bunkers until things clear up, or build multiple space stations that could fit us all. Yeah, right. The chances of all volcanoes erupting at once, though, are very slim. Whew! That's because there isn't one giant source supplying all the volcanoes on Earth. Each one of these openings has its own deposit of magma, except for a few cases where they indeed share the supply. For example, in 1912, Nova Rupta in Alaska erupted alongside another volcano sharing magma. Scientists have also found evidence of magma hiding under volcanic areas, like under the Taftton volcanic zone in New Zealand. This magma can spread out horizontally for long distances, but is still just a local feature. Even if we consider all the magma under Taftton as one system, it's not connected to other volcanic areas like Indonesia or the Philippines. Because the great majority are isolated, volcanoes can't sync up to erupt at once. The magma comes from different processes like mantle decompression or adding water to the mantle through subduction. There's no way to make all these different volcanoes erupt together because of how tectonics work. Now, that doesn't mean we won't see interesting volcano activity in the future. Take an underwater area near British Columbia, where recently about 200 small earthquakes per hour have been noted. Deep beneath the Pacific Ocean floor, off the coast of Vancouver Island, magma is set to erupt, heating the water so much that it'll bubble like soda. However, this event will likely go unnoticed by anyone other than scientists. The anticipated eruption will most likely happen around 3 miles below the ocean surface. Scientists explain that the earthquakes range from negative to 4.1 magnitude, meaning only those nearby would feel any tremors. This unusual activity gives us a rare opportunity to study how the Earth's crust forms. The magma beneath the ocean floor is estimated to be almost 1,500 degrees Fahrenheit, but will cool rapidly upon eruption and contact with water. This runny rock will solidify upon contact with the seafloor, turning black quickly. This event will be useful for biologists too, who will have the opportunity to study the marine animals' response to any changes, like run! Antarctica, often seen as a vast icy continent, also holds a volcanic surprise beneath its frozen surface. Researchers have identified over 130 under the western ice sheet alone, making it the largest volcanic region on Earth. Most of these volcanoes, about 90, were only recently discovered in 2017. But could any of these Antarctic volcanoes actually erupt? Well, it depends on which volcano we're talking about. While these formations are relatively young in geologic terms, it's hard for scientists to tell if they're still active or not. There are only 2 confirmed active volcanoes in Antarctica, Deception Island and Mount Erebus. The latter, standing tall as the highest peak on the continent, has been continuously erupting since at least 1972. It's known for emitting gas and steam, and sometimes even throwing out rocks in what are called strombolian eruptions. One of its most notable features is a persistent lava lake in its crater, a rare phenomenon due to specific conditions needed to keep the surface molten. For instance, it's fueled by a steady supply of magma from deep within the Earth's mantle. This continuous inflow of molten rock provides the material for the lava lake to exist. It also features low ambient temperatures. Despite its location in Antarctica, Erebus has relatively mild temperatures in its summit region because of the heat generated by the volcanic activity. This allows the lava lake to remain liquid rather than freezing over. Deception Island, another active volcano, last erupted in the 70s. While it's currently not showing signs of imminent eruption, it's being monitored closely for any concerning activity. Apart from these 2 being confirmed to be active, Antarctica is dotted with fumaroles, openings in the Earth's crust that release gases and vapors. Sometimes these fumaroles can create icy towers reaching heights of 10 feet. What we should focus on is maybe supervolcanoes. They're this type that has the potential to produce the most massive and destructive eruptions. Unlike the typical one, which has a single vent, supervolcanoes have a vast magma chamber beneath the surface, spanning tens or even hundreds of miles in diameter. Their eruptions can have catastrophic effects on the surrounding area and even impact global climate patterns because of the amounts of ash and gases they spill out into the atmosphere. One famous supervolcano is the Yellowstone one, which some say is gearing up for another eruption. It has the capacity to unleash a colossal eruption, spewing over 240 cubic miles of material. As much as we'd like to predict its behavior, volcanoes don't stick to a calendar. On the contrary, eruptions simply happen when there's enough magma beneath the surface. There also needs to be enough pressure for the magma to travel upwards. As far as we can measure, these conditions are not currently met at Yellowstone. Sure, many volcanoes operate on a cyclical pattern, but that doesn't mean Yellowstone is overdue. In fact, Yellowstone has had just 3 major eruptions over the past 2.1 million years. Also, the term supervolcano refers to the formation's size, not necessarily how fussy it is. Yellowstone's monitoring is extensive, tracking seismicity, ground deformation, thermal emissions, gas, water chemistry, and surface changes. Signs of an eruption would include thousands of earthquakes over a short period. We'd also see deformation on the ground and weird gas emissions ahead of time. Stable, as it might look like for now, the consequences of it having a major eruption could look ugly. Ash dispersion could blanket a 500-mile radius, potentially disrupting Midwest agriculture and clogging waterways. Ash and gas emissions into the stratosphere could induce global climatic effects, making our planet colder for several years. And yes, we've seen some research that it shows there's more liquid molten rock under the Yellowstone volcano than scientists believe. But that doesn't translate to imminent danger.